Hello and welcome, my dear students, to my channel Mathematics Made Easy. Today in this session, I've got a very important video for you based on Chapter 5 Systems of Equation and Matrices. So this is useful for any grade, any section who wants to learn matrices very well, especially for grade 11 advanced. So in this video today, we are going to work on the Gauss-Jordan elimination method, very important. And if you really want to understand the elementary row operations, you want to know what is an augmented matrix, and you also need to see the steps to solve matrices problems and get the solution of a system of equations in three variables, then you must watch this video till the end. Make sure you share it with your friends so that they can also benefit. And this video is covering questions from lesson 5.1, and this is very important video to watch and understand if you really want to understand the chapters that are in your syllabus, in your curriculum, like 5.2, 3 and 5. So let's get started. This video is especially for grade 11 advanced, and let me know in the comment section which is the next topic that you want in my videos to help you for understanding math for term 2 better. So the following slides tells you the elementary row operations. You can use this elementary row operations to solve questions on Gauss-Jordan method. So what does these operation mean? Let's see. So these are three varieties of row operations that will give you equivalent system of linear equations and solution. First is you can interchange any two equations or any two rows. So R1 change to R2. So I can interchange them. This is how you write the elementary row operation of interchanging the equation. Next, multiply one of the equations by a non-zero real number. So for example, I apply the operation R1 becomes 3 times R2. Okay, so you just multiply, or maybe I keep the row same better. So R1 becomes 3 times R1. That means I multiply the whole first row with the non-zero number 3. And then you can also add a multiple of one equation to another. So means you can make your R2 say R1 plus 2 times R2. So you can also add them and then multiply. So all of these are elementary row operations. We'll be using them for solving questions on Gauss-Jordan elimination. Another very important term that you should know before we move to the questions on Gauss-Jordan method is how to convert the system of given equations into an augmented matrix. So what's an augmented matrix? Let's understand. Uh, Before you get in your exam a question like this, first thing you need to analyze how many equation, how many variables. So 1, 2, 3. Generally, you will get three system of equations in three variables. So x, y, z, these are the three unknown variables. So from these equations, you have to convert first and get your augmented matrix. And for that, we will be using the help of coefficient matrix. So you can write the system of equation in matrix form in this manner. Let's write it first and then we'll find the augmented matrix and the coefficient matrix. So look at the coefficients, numbers plus 5 minus 5 minus 5. So I write them in the first row. This is my first row. Then second row, minus 1. If you don't see a number, means it is minus 1. Don't take it 0. Otherwise, it will give you wrong answer. So if you identify your coefficient matrix correctly, that's step 1 of getting the correct answer. Then this is your coefficient matrix. Let's write the variable matrix. So x, y, z, three variables, three unknowns, I put them. And this is going to be equal to, because of this equation, the coefficients on the right. So 35 minus 12 and 30, these are the constants. So this is your ax equal to b system of matrix equation. What is a? The coefficient matrix, you already found it. X is your variable matrix, which has all the three variables that you need to find, and this is the right hand side of the constant matrix b. Now, how do we find augmented matrix? So when I combine my coefficient matrix, this one, with my constant matrix, which is on the right, I combine them two and I put a broken line in between. I hope you all can see that. And what we get is an augmented matrix. So it will have all the numbers coming from the coefficients and all the constants coming from the right side of the equation, and you separate with broken line. So this dash line, this broken line separates the coefficient matrix from the column of constant matrix in an augmented matrix, and we'll be using this augmented matrix for solving questions on Gauss-Jordan elimination. So let's get started. So let's take an example of an augmented matrix and try to write it. I just want you to be confident in this so that you don't do any mistake. So do you see three equations? Let's number them 1, 2, 3. The right side has already the number, so no problem. But if you see left side, the order is different. Here you have W, but here you have X. Here you have both X, but here you have Y. Here you have Z, Y, Z. So it's not in a proper order. So let's write them in a proper order first. So if I follow the order of the first equation, that means I write my W first, X later, and Z later. Then this is the first equation. Now in below 4W, I will put only W's from the two equations. So there is no W in this one, so I keep it W. But if you see, there is only also variable Y involved, which is missing. So let me introduce Y also. So plus 0Y. And now in below X, I'm going to put all my X's. So now we are in the correct form. Below Z will come variable Z. You don't have Z in the second equation, so it's 0. However, for the third equation, it's 10Z. For first equation, there's no W, we already put 0Y. So here now below we will have 3Y, and here we have minus 2Y. So please be careful with the variables. If you put them in the wrong order, your augmented matrix will be wrong. So now just keep the numbers. So 4, minus 1, 0, minus 5, plus 8, plus 15, 7, 0, 10, 0, plus 3, minus 2. These will give you the coefficient, and the numbers on the right, minus 11, 6, 9 will be differentiated uh, with the dash line, and this is how you get your augmented matrix. I hope you understood how to write it, and now you are ready to solve some questions on Gauss-Jordan elimination. Let me first show you a solved example, and then together we will solve a question on Gauss-Jordan elimination. Okay, so you see the system of equation. There are three equations. Let's number them. Let's look at the variable x, x, x. Okay, it's perfect. Y, 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 z, z, z. Perfect. So we are ready for writing the augmented matrix. That's step 1 of any Gauss-Jordan elimination method. So we write it in this form, take the coefficients, and this is what we get. Now, our target is to get the identity matrix in the augmented matrix, which is this one, and then whatever is the value you get here, x, y, z, whatever numbers you will get here would be giving you your solution. So this column matrix, after you did all the row elimination and row elementary operations, the values that you get here will be your solution. So let's first try and do that. So if I want to convert from this to this, I need zeros here. So I will apply the operation to the second row. So second row operation I apply, R2 becomes R2 plus R1. Why I do that? Because these two are opposite sign, plus 1 minus 1. So this will become 0. So this second row changes, first and third row is as it is. Next I want to change this 2. So definitely I have to subtract 2 times the first row from the third row to get it. So let's apply more operations in the next slide. Okay, so now I transform my third row. I apply the elementary operation. R3 becomes R3 minus 2 times R1, or you can write it in this order also. You can mark it here, and then you get these two zeros. So we are in the correct form. Now we want to convert to identity matrix or the row echelon form, whichever you say. So I will try to make this term also 0, and how I can do that? By adding the second and the third row. Okay, so the next transformation will be on the third row, where R3 becomes R2 plus R3. Add them. So this term becomes 0, and we are on the right track. Now all the diagonal elements have already become 1, so this is perfect. Now I need to make the non-diagonal elements, means these three. as 0. If we are able to do that, we are done. So let's now change the first row. So in the first row, I add the first and the second row, and the reason for doing that is so that you get a 0 here and a -1. So now I can just use the operation of the first and the second row. So the first row R1 becomes R1 plus R3, and if you're wondering why we did that so that uh, the new value that we get for the first row, when you add this -1 and this +1, it will cancel and give you this 0. So we are on the right track. Now the only term we need to change is -2 and make it 0. So let's do it with another elementary row operation. Next slide. So this is the last and final step where we do the transformation in the second row because I wanted to make this term 0, and for that I make R2 as R2 plus 2 times R3, and that gives me the identity matrix. So these three values of the column are your values. So this one is X, this one is Y, and this one is Z. So solution is X equal to -2, Y equal to 1, and Z equal to 3. You can also write it as an ordered triple where X, Y, Z are written in the proper order. Okay, so you can also check your solution, put it back, and you'll get it. Now there's a tip for you. You can do this features on your calculator also. So you can use technology to make your life easy and use the shortcut. So let's solve this question using Gauss-Jordan method. I'm going to show you all the steps. I want all your attention. And we are going to be solving this question by applying elementary row operations. Also, we will use the augmented matrix. So what is this augmented matrix? Let me tell you. So first we look at the coefficients, the numbers here. So nothing means -1. This one, all numbers, all coefficients we take and we write the coefficient matrix. So the coefficient matrix is 4, -1, 2. So all coefficients of x, then all coefficients of y. So 9, -2, 4. So coefficients are the numbers in front of the variable. So if variable is y, the number in front is +9. Also you take the sign, so it is -2 here. Now you write for z, so 16 -4, 9. So this is your coefficient matrix. Now if I want to write augmented matrix, then I just put a broken line and I put the coefficients here. So coefficients are the numbers on the right side. So this will be 2, -1, -5. So this is my augmented matrix. Now I'm going to apply these elementary row operations to this matrix. Our goal would be to get the identity matrix here so that we get the values of the variable x, y, z. So what we need to find here, we need to find the values of x, y, z. So let's apply one by one the row operation. So first thing which you should observe is the second row. In second row, everything has negative sign. So let's apply the operation. R2 becomes minus R2. I just multiply the second row with -1, this row, and the reason is so that everything becomes positive. So I get 4, 1, 2. The first row and the third row will be as it is, no change to them. The only thing that changes is the sign of the second row or the middle row. So it all becomes positive. Okay, so now we are in a better position. Now we need to do some more row operations. Now because I want to make it identity matrix, so what should we do? We want this to be 1. So how can this be 1? If I can use this row in that operation. So let's see how this 4 will turn to 1 if I subtract 3 from it, and 3 is 3 multiplied by the second row. So now the elementary operation that I do, I'm writing it here, is R1, the first row, becomes R1 minus 3 multiplied with the middle row. Similarly, I want to make this also as 0 because I want identity matrix. I hope you remember, I will write here in the corner that identity matrix has 1 in the diagonal and remaining all numbers not in the diagonal are 0. So we want this. Okay, we want to convert this coefficient matrix into this. It means we want this term 2 to be 0. So that's why the next operation I do is R3 becomes R3 minus 2 times R2, because when I subtract 2 times 1, it will become 0. Okay, so let's do this operation. Now when we do this, the result would be this matrix. I will write it here. So we are applying the operation on the first row and the third row. So the middle row will be same, no change. 1, 2, 4, and 1. Okay, now what will change is the first and the third row. So let's change the first row first. So 4 minus 3 times R2. So 4 minus 3, that will give you 1. Then 9 minus 3 times 2 is going to give you 3. Then 16 minus 3 times 4 is going to give you 16 minus 12, which is 4. Similarly here it will be 2 minus 3, which is minus 1. Okay, let's do the last row. So in last row, we are subtracting 2 times the middle row. So this is 0. This is what we want. Similarly, 4 minus 2 times this also becomes 0. Wonderful. And 9 minus 2 times 4 means 1. Okay, so if you see, the last row is done. This is what we wanted. So R3 we have already got, and similarly minus 5 minus 2 times 1 would give you minus 7. Okay, so we have got this number correct and the last row correct. Now what we want more, we want this to be 0, we want this to be 1. Okay, and all other 3 4 4 to be 0. So let's do some more operations. Now I will move to the next slide to show you some more elementary operation which will help us to reach the identity. Okay, so now we do R2 becomes R2 minus R1, and when I do that, the matrix changes. So the augmented matrix becomes 1 0 0, 3 minus 1 0, 4 0 1, and the coefficients in the augmented matrix also change. Okay. Now, what else we want to do? We want this middle row to have all positive sign, this number to be 1. So I'm going to apply the next operation. R2 becomes minus R2. I change the sign so that this term becomes positive. So 1 0 0, 3 1 0, 4 0 1, and the first row and the third row same, only change in sign for second row. So now we have got this part and this part and this part correct. So I just need to change now 3 and 4. So how will I change? I will again apply row operation. So I want to make this term as 0. So what do? We use the third row. So the next operation I will do is R1 becomes R1 minus 4 times R3, because I'm using this 1 to make this 4 0. So it becomes, okay, second and third row same, no change. Just copy. And let's change the first row. So this is 1. Now this becomes 3 minus, this will be 3 minus 0 only, because this is 0, and this term becomes 0. What about this? It becomes minus 1 minus 4 times minus 7. Okay. So next step, we get 1 0 0, 3 1 0 0 0 1. So one more last step we need to do so that we get our answer. So this is 28, 7 4s are 28 minus 1. 27, and yes, we just need to change this 3 now. We want to make it 0. So for that I will use now the second row. So the last operation we will do here is R1 becomes R1 minus 3 times R2, and I do that to make this term 0. So what do we get? Second and third row is the same, no change. I will just change this one. So 1 is as it is. 3 minus 3 times this becomes 0, and this is also 0, and 27 changes. So it becomes 27 minus 3 times minus 2. So just add, and finally we get our answer. We have reached to the identity matrix. So the solution, the numbers on the right, it is 33, minus 2 and minus 7. So what's your final answer? We need the variable. So x is the first variable, equal to 33, y is the second variable, equal to minus 2, and z is the third variable, which is equal to minus 7. So this is our final answer. That completes Gauss-Jordan elimination method to get your solution XYZ. So I hope you found the video useful and you understood nicely how to use the Gauss elimination method. Use it to solve this question and check your answer. This is your homework for today. And now we come to the end of today's session. I hope the video helped you, and see you in the next session. Don't forget to like, share and subscribe to my channel to get more math videos that will help you for your exam. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye students.